So we are going to talk about the box problem. Now, the box problem is very common in a pre-calc and calculus class. So even if you want to get a sheet of paper from the back table and there's some scissors back there, grab some scissors and follow along. It says, consider what is involved in building a box without a top from an 8.5 by 11 sheet of paper by cutting squares from each corner. So they have shown us here that they have cut squares. So remember, these lengths would be the same. So we know we can say that this is length X and this is length X from every corner, okay? Now it says that we are going to cut 4 equal size squares from the corners, fold up the sides, and feel free to tape them together, or you can just hold them for a moment. Now, the question B says, do the cutouts have to be a square? Well, think about if you did not make them a square, it would not make a box. So it would not line up correctly unless it is a square. Describe each quantity with a varying value. Then describe each quantity with a fixed value. So the size square that you cut out and the size square that your neighbor cut out could be different. So we're going to let X be the side length of the square. And that would be varying. Where the 8.5 by 11 size paper is a fixed quantity. Okay, so that's what they wanted to talk about there. Then it says, describe how the configuration of the box changes as the length of the square of the cutout increases. So as the length of the side of the square cutout increases, it would change the volume of the box, and our box would, well, it would be a box with very long sides and a short, stubby, center portion. So what you can think about is, if we're cutting those out of the corners, as we get larger and larger, that's not quite a square. So that 8.5 by 11 is going to restrict us. So think about that would be 8.5, half of that is 4.25. So we could go 4.25 and no more, and we would end up using the entire side. So we wouldn't have a side to fold up. So we really can say that our X, for it to be a square at all, has to be bigger than 0 and has to be less than 4.25, because as soon as we hit 4.25, there's nothing left to fold up. Determine the values of each of the following every box. Our box's height. Okay, so now we have folded it up. What is left? Okay. So this would be here, and that we have taken that 11 and we have cut out 2 X's. Here, let's assume that goes with this. We have taken out the 8.5 and we have cut out 2 X's. And so, but our box, the height of your box is your X, the height of my box is my X, so that would just be X. So the box's height is the size of the square. The length of the box would be 11 minus 2X. The width of the box would be 8.5 minus 2X. Now, what's the volume of a box? A volume is length times width times height. That should be something you remember from your algebra classes. So the volume of this box would be x times, well, let's go in the order I said it. So let's go length, in parentheses, 11 minus 2x, times width, 8.5 minus 2x, and height, x. So that is the volume of the box. It says, describe how the volume of the box varies as the length of the side of the cutout varies from 0 to 4.5. Well, let's plug in 0 into our volume equation. We get 11 times 8.5 times 0. It can't have any volume if it's just a flat sheet of paper. We've not cut out anything. But let's plug in the 4.25. If we do, well, let's start with 4. So then we can get a sense of something in between there. 11 minus 8 is 3. 8.5 minus 8 is a half. And our x, I said, was 4. So this is when x is 0. This is when x is 4. So that would be 0, or I'm sorry, times 4. And so that would be 6, and that would be cubic inches. We could even put 0 cubic inches. Look what happened when we get that 4.25. It will come back to 0 again because of this spot right here. So we would end up with 2 times 0 times 4.25. So we know our volume is somewhere between 0, at least 6. There is going to be a way eventually that we'll talk about finding that maximum volume. And that is related to its algebraic equation that we see up here. When you get to a calculus class, you'll explore even more how to find that maximum volume. So that's a little intro to the box problem. Now that we've done the box problem, please open up your iPad to your pre-class M3.2. Pre-class M3.2. I'm going to walk you through it. Now remember, my numbers and your numbers might be a little bit different, okay? And then this pre-class, they're talking about function relationship. They're talking about how that dependent variable y is related to our independent variable x. There we go. The values that we can use for our independent variable are the domain. I'm going to just use a D for domain, and those are the values of Rx. The range, I'm going to just use a plain old R. This is the R I'll use for real numbers, just so you know that in the future. And that are the values of our Y. Or if we use function notation, that's the values of the f of x. So input, those are our domain values, the x's. Output, the range values are our y's or our f of x's, our output values. Okay, so let's take a look at what we see here. It says, we're going to consider an example. We're going to imagine a map of a state where 1 inch on the map represents 28 miles of actual road. So I'm going to make a little note to myself. 1 inch on the map, see what I just did there? Sorry about that, is equal to 28 miles on the road. Okay. So it says define a formula to represent the distance on the road in terms of the number of inches on the map. So let's just logically think about it. If there's 1 inch on the map, it's 28 miles. If there's 2 inches on the map, we just have to have 2 times 28, and that's how many miles it would be. So that kind of is going to lead us. And remember, if it uses the word formula, we want to equal to. And so our D would equal 28N. So D is the number of miles on the road, and N is the number of inches on the map. Now it says, if the longest driving distance across the state is 434 miles, what is the maximum length of the inches from one side of the map to the other? Well, we can use that formula we have created. We know that 28 uh, is our, you know, our proportion, our proportionality, our scale. And so if we have the distance being 434 miles, the n would just be the division. Now, again, your number and my numbers might be a little different. Please note that. But to solve that, you're just going to divide by 28. So I got 15.5. And that would be on the map. Remember, our n is our, this is our n, is our map. So make sure that is inches. Okay. And then it says, determine if the following statement is true or false. The driving distance is miles is a function of the number of inches measured on the map. That is true. Remember, a function of is something that has that perfect relationship between the independent and dependent variable. Every independent variable is just paired up just once. You always get just one answer. So it would be a function of that independent variable, okay? Recall that a function's domain describes the possible values of the independent variable. What is the domain of the function that defines the actual distance in terms of n, the number of inches on the map? Using interval notation. So they said the biggest number we're going to get in miles. So we're looking at the domain of the distances in miles. We can have nothing on the map, and we can have 434 miles. Now again, mine says 434. You only want to put the brackets, and you want to put brackets around both. That means that you could have nothing or 434. Now, if that doesn't work, I would suggest trying a parenthesis on the 0 and a bracket on the 434. What does that mean? Well, a 0 isn't going to show on the map, so it's going to be something bigger than 0 to be on the map. But 434 is our biggest thing on the map. So if this doesn't work, try that one. Again, I don't have the capability to do any of that right now. Okay. And then it says, recall that a function's range describes the possible values of the dependent variable. And so, okay. So I made a mistake here. See how they mentioned D. So again, that's what you want there. Those are the possible outputs or the miles. Remember, miles are our range values. So this would be our range, would be miles. Our domain would be inches. I apologize for that. Now, we know that 15.5 was the biggest n that would be on the map, so that one goes from 0 to 15.5, or possibly parenthesis on the 0 and 15.5 with a bracket. Okay, so I apologize for that, but we're going to discuss domain and range interval notation a little more as the week goes on. All right, let's take a look at this one. It says in the graph here, they've shown that it's 28 times larger on the corresponding distance on the map. Okay, so and you can use that type of relationship. See how here it is the distance on the map in inches, and this is 28 times larger. So if you do 1.25 times 28, you get 35. 1.25 times 2.7 gives you that. Remember, our equation was this. Now, you might not use 28 on yours, but okay. Okay. It says, determine if the following statements are true or false. As you imagine n increasing from 0 to the largest value, in the previous question, each value of n is paired with exactly one value of d. That's true. And then the point 6.5182, conveys that it will take 182 minutes to travel 6.5 mile or inches on the map. That is false. Remember, it's not a bad idea to go, this is ND, this is inches on the map, this is miles on the road. So keep in mind what your X and Y happen to be. And here's your X, here's your Y. And so the point, that would be the distance on the map. That would be the distance in miles. This is a really nice picture. I will explore that more, but basically a function just tells us if we input something into that function rule, and this mine is 28n, then we get an output. So in this case, the input, the independent variable is our n. The output, our dependent variable, is d. And then here we have a graph, and it says, determine if the following statements are true or false. If the relationship defined above the graph, y is not a function of x because multiple values of y are associated with a specific x, that is true. It is not a function. So that one's true. In the relationship defined by the above graph, x is not a function of y because multiple values of x are associated with a specific value of y. Now, one thing that's interesting about this one is you are used to a vertical line test. This one is actually a function. X is a function of y, which is normally not something we talk about too much, but that one is false. There's something called a vertical line test if you're checking for a function being a function of x, and then that just says vertical lines can only hit the function once. Well, if you do horizontal lines, you're checking to see if it's a function of y, and this one is a function of y, so that's why that one's false. And that is basically that. So hopefully that helps you get you through that pre-course M3.2. So work on your iMath. There you go.